Hello, everyone. My name is Thomas Blennerhassett. I'm the Associate Librarian at the Michener Institute and the Associate Librarian at the Learning Resource Collaboratory at that institution. So pleasure to be here. Thank you for having me in. I'd like to thank Tim and Raluca and Melanie for being present, particularly Raluca and Melanie because they'll be moderating this session. You can check the chat. They have some instructions there. I am to be pausing periodically just to take some questions. So if you put your questions in chat as we go, I'll take a few minutes here and there just to answer those so we don't get an overwhelming amount of questions at the end. But with no more ado, let's dive into Introduction to Research Data Management. And I'm just going to, there we go. So this is me. Hi, this is a giant picture of my face. Again, I'm Thomas Blennerhassett. I'm the Associate Librarian at the Learning Resource Collaboratory at the Michener Institute. You've got my email here if you want to get in contact with me. I'm sure that there will be questions after this presentation, and we may not have time to get to everything, so I encourage you to reach out directly to me or to Tim and his team if you have any questions about some of the topics that we touch on today. And actually, before we get started, sort of a special announcement and sort of a moment to set the framing of this. This workshop today is going to be focused on sort of the principles of research data management. What are the core tenets of this concept? How does it work? What are the sort of rules around it, as well as some best practices? But we do actually have some members from UHN Research in today. I think that they are in the crowd. And they have actually some more UHN specific information that they've said that they'd like to share at the end of this presentation. So while I go through, oh, hi, Michael, I can see you. Michael Voth has just raised his hand in the chat. So we are going to be calling at you at the on you at the end, just to provide a little bit more context about some of the amazing things you guys have been working on. But my workshop and presentation is more about the basic tenets, an introduction to the topic if you're unfamiliar with it completely, as well as just a bit of the context surrounding some of the Tri-Council policies. What are the sort of the basic building blocks of research data management and how to begin a research data management plan, as well as why it's important and who some of your contacts are. So I just wanted to set the stage a little bit there. Michael, forgive me, we'll get to you at the very end. And I think lots of people would love to hear about some of the stuff that you've been working on. I know I've been very interested to hear about it. And with no more ado, let's continue. So today we're going to be talking about a few things, and I'm just going to put them in order here. So we're going to be talking about the library's role in research data management, and I'm going to be talking a little bit about Tim Tripp's team and some of the things that they're doing, but also, why the library in general is involved in a topic like this and what kind of support we generally provide. We're going to talk about what RDM is, so like what is this very amorphous concept called research data management. We're going to put that into focus for you. And what I like to do in my presentations is I like to talk a little bit about why this particular subject matters, why it should be important to you, and why you should care. I like to do that because I think it makes people a little bit more invested. We're going to be talking a little bit about the very basics, RDM 101, I'm calling it, and we're going to talk about a few of the concepts, the definitions, what kind of things are involved in RDM. As well as RDM plans and how to start making one. This is a big question. I get this a lot when I do this presentation. This is a huge topic, and how do I get started? What are the tools available to me, and how do I move forward with it? Because it's an important topic, as I think you'll find out. And people start to get a little panicked if they realize that maybe they're not completely caught up or haven't considered this in as much detail yet. And I'm here to tell you that that's, take a deep breath. It's going to be okay. We're going to talk about research data management plans. The best time to start a research data management plan is now. If you're doing research, and we're going to cover a few of the tips, tricks, and tools that'll help you do that, as well as talking about data deposits and making your data sort of available and open and transparent, and then some resources right at the very end. And of course, we'll be taking some questions and unmuting people at the very end and allowing UHN Research, and Michael Voth, I believe, is the one who's volunteering to do it, to talk about some of the more UHN specific plans that are in motion. So why the library? Why am I a librarian and associate librarian at the Michener Institute coming to you and talking to you about research data management? So the library is a research partner. We're very, in this particular institution, we're not so discipline agnostic. We are experts in health sciences and medical sciences. But in many other institutions, you'll find that the library has a number of subdivisions, a number of specialist subject librarians, and you may even belong to some of those organizations. So I want to make the point that librarians are typically discipline agnostic, and it allows them to focus more on the concepts of research data management rather than the nitty-gritty of sort of what you are in particular researching, although that information can be very helpful. It's a partnership where we bring our specialization in information and knowledge management, and you bring your subject matter expertise. We work together and we create research data management plans that best reflect you and allow you to succeed. We sort of sit at the confluence of advancement of research, consultation, and information. We allow all of these different sort of concepts to come together at one point and allows us to work together a little bit seamlessly with researchers. We can typically help you find research data, understand the data management requirements of different funding agencies. We can help you create a research data management plan, and I'm going to cover this in a little bit more depth in a second. We can choose an appropriate repository so we can help you make those choices, and we can understand the best practices for disseminating and archiving your data. This is something that archiving in particular is something that librarians and information specialists pay a lot of attention to because we want to make that data available in the future. And as you'll see, that's actually something that's becoming more and more difficult because of the nature of sort of modern existence. But we'll cover that in a little bit more depth later. What I do want to say specifically, though, is that Tim Tripp and his team are amazing. They are, highly skilled at this, but they're also sort of beginning their research data management experience. And they've expressed that they would be interested in sort of co-learning with you as you move forward. So while they can definitely answer a lot of questions, and I myself have made myself available to answer anything that comes up, they don't specifically offer this as a service, as a formal service quite yet. And so I just want to cover that a little bit. If you have more questions about it, Tim is in the chat, as well as Raluca and Melanie, who can also offer some more UHN specific viewpoints. I just don't want to, put them out there as being your primary contact. They can definitely answer a lot of these questions and help you make a lot of these decisions, but just keep in mind that they are also learning at the same time as you. So I think that this is what a lot of people came here for, because what is research data management? This is a big topic. I think a lot of people struggle with this because they don't know where to begin. And because I'm a bit of a nerd, I like to break things down into basic topics and give you an introduction. And so some of this may be stuff that you already know, but I just want to do this in a more formal manner and walk you through this topic in depth. So research data management is just a general term. It covers how you organize, structure, and store and care for information that you create during a research project. There was a philosopher of science who said that the major creation of research is not actually information. What it is paper. Research creates a lot of like physical paper. This was an article that was written back in the 80s before everything was digital. But what the point is that research creates a lot of stuff that just kind of builds up over time, and it may build up in a way that you were not initially anticipating, and that can make it very difficult to organize and structure your data. And then in the future, it can make it especially difficult to share that data if you're not putting thought into it immediately. So a research data management and a research data management plan is it's a way of keeping your house in order as you move forward. It's planning how your data will be looked after, after you are done with your research, or maybe after you leave the research team. And many funders are now requiring that you have an RDMP or a research data management plan as part of applications. So it's important for when we're looking for funding. It also handles how you deal with information on a day-to-day basis. It gives you sort of a guide, an order of operations in the way that you develop, create, and then store information. And it shows it over the lifetime of a project so that things don't just sort of fall off the edge. What happens to data in the longer term? So this is when we start talking about like archives and archivization. What do you do after the project concludes? We'll see I've got a video that I'll be showing that shows one sort of outcome of this. But there are many ways that you can plan to let your data be shared after your project is finished. And it's actually very important, as we'll see, because there can be consequences for not planning for that. So what is research data? Like, what is this stuff that we're talking about? So research data are collected, observed, or created for the purpose of analysis to produce and validate original research results. It's the stuff that proves your point. So when you write a research paper, you are using your research data in order to basically back up your point. And what's really important is that if someone comes along and says, wait, I don't understand, can you show me your data? Research data management allows you to do that in a more structured, organized, and accessible way, because that is a question that's happening more and more now. So research data can include your measurements, your interviews and transcripts. That's a big one for social sciences and humanities. It can include photos. So this may be photos of cells, or it may be photos of you out on ethnography, etc. Audio recordings. So for instance, interviews or recordings even of meetings where you're deciding sort of major aspects of your project. This can all be included in research data. All the notes that you take during the production of your research. And then I just have etc. at the end, because no research data management plan can, or research data management description can encompass sort of all of the various things that are created when you're beginning your research, or even in the midst of your research. Some of this may need to be added later in as you realize that you're creating data that needs to be stored in an organized manner. So why does this matter? So this is a big question for me. It's like, why should you care? Like, why should you dedicate your time to come and watch me talk about this for an hour? And we're going to talk a little bit about funding requirements, reproducibility, and the ability to share. These are all really important, and some of them are more serious than others in terms of the consequences of not doing it. But so for you, proper research data management can make it easier for you to find your files. It can make it easier for you to keep track of your data and the versioning of your data. It can make it easier to organize, compile information at the end of your project as you look back and you sort of look at all the things you've produced, sometimes over the course of years or even decades. It's easier to organize that and then sort of put it to rest at the end, or to produce something at the end that incorporates all that data. It can be used to reproduce your work. Now, this is more and more important for modern researchers. This is something that I think in the past was not given enough importance, and that has had consequences, which we'll talk about. But if your journal or patent or a funder is asking for your research data, you should be able to provide it, and you should be able to provide it in an organized and accessible manner, which you'll see in a minute. You should be able to pass on your work to another researcher if you're comfortable with it. In some cases, your funding may require it, but you should be able to pass on the proof of your point to someone else who's looking to reproduce that, as well as just generally share your work. Research data management just makes it easier, and research data management plans make it easier to just, behave as a researcher in the modern world and be able to share those things with other people, and to advance the general idea of, capital R research. The other thing is that it's satisfying grant requirements. We're going to talk a little bit more about this, but the Tri-Council policy is out, and it's very specific that you should be having these things. It highly recommends them, as well as the fact that our RDMPs are now being considered when funding applications are going in. And so this can make the difference between potentially getting a grant and not getting a grant, is including a well thought out RDMP. Satisfy research ethics boards and institutional requirements. So this is something that if you belong to U of T, UHN, the Michener, etc., this is something that you may have to consider, as well as satisfying journal requirements. Some journals, not all journals obviously, but some journals do require you to have a plan to share your data in the event that someone asks, or in the event that they ask. So these are all things that you should be keeping in mind. Satisfying grant requirements, as I mentioned, the Tri-Council, so that's SSHRC, CIHR, and NSERC. I'm sure most of you are familiar with these organizational bodies, but we'll be talking about them a little bit later in the presentation. The agencies believe that research data collected with the use of public funds should be responsibly and ethically and effectively managed, and belong to the fullest extent possible in the public domain and available for reuse by others. So this is both an open access statement, but also research data management plays into this effectively managed section of this statement. The agencies encourage grant applicants to complete data management plans, or DMPs, I know a lot of acronyms, as an essential step in research project design. So this is an essential step. For specific funding opportunities, so not all funding opportunities, but very specific ones that they do list on their website, the agencies may require DMPs to be submitted to the appropriate agency at the time of application. In these cases, the DMPs may be considered in the adjudication process. So it's their statement on that. This gives a lot of people the heebie-jeebies, but really all they're asking for is to keep your data organized and shareable, essentially. So what we're going to do is we're just going to take a quick look at when things go wrong and what ends up happening when you don't take these principles into your plan when sharing things. So I'm just going to pop over to YouTube, and I'm going to make this theater mode. Going to start. This is about 4 minutes long.
Hello, my name is.
Can everyone hear me? Raluca, can you unmute and just let me know that everyone can hear this?
Dr. Judy Benign. I'm an oncologist at NYU School of Medicine.
Hello, Dr. Judy Benign.
I read your article on B-cell function. I think that I could use the data for my work on pancreatic cancer.
I am not an oncologist.
I know, but I think I could use the data for my work on pancreatic cancer.
I'm just going to quickly preface this because some of you may have lost the context. The white and black panda is asking this other cartoon character for their research data so that they can do their own research using that data and sort of use it to support their points. As you will see, that there's going to be a breakdown in the way this sharing happens.
Do you have the data?
Everything you need to know is in the article.
No. What I need is the data. Will you share your data?
I am not sure that will be possible.
But your work is in PubMed Central and was funded by NIH.
That is true.
And it was published in Science, which requires that you share your data.
I did publish in Science.
Then I am requesting your data. Can I have a copy of your data?
I am not sure where my data is.
But surely you saved your data.
I did. I saved it on a USB drive.
Where is the USB drive?
It is in a box. It is in a box at home. I just moved.
But can I use your data?
There are many boxes. So many boxes. I forgot to label the boxes.
Hello again. Thank you for sending me a copy of your data on a USB drive. I received the envelope yesterday.
You are welcome, but I will need that back when you are finished. That is my only copy.
I did have a question.
What is your question? You might find the answer in my article.
No. I received the data, but when I opened it up, it was in hexadecimal.
Yes, that is right.
I cannot read hexadecimal.
You asked for my data and I gave it to you. I have done what you asked.
But is there a way to read the hexadecimal?
You will need the program that created the hexadecimal file.
Yes, I will. What is the name of the program?
Cytosynth.
I do not know this program.
It was a very good program. The company that made the program went bankrupt in 2007.
Do you have a copy of the program?
I do not use this program anymore because the company that made it went bankrupt. Maybe you can buy a copy on eBay.
I have good news.
You again.
I talked to my colleague. She knew a person with a copy of the software.
Then why do you need me? Everything you need to know about the data is in the article.
I opened the data and I could not understand it.
If you have the program, you will find it is clear.
Well, I noticed that you called your data fields SAM. Is that an abbreviation?
Yes, it is an abbreviation of my co-author's name. His name is Samuel Lee. We call him Sam.
I see. And what is the content of the field called SAM1?
Ah yes, SAM1 is the level of CXCR4 expression.
And what is the content of the field called SAM2?
That is logical if you think about it.
What is the content of the field called SAM2?
I don't remember.
What about SAM3? Is there a guide to the data anywhere?
Yes, of course. It is the article that is published in Science.
The article does not tell me what the field names mean. Is there any record of what these field names mean?
Yes. My co-author knows what the content of SAM2 is, and SAM3. And SAM4.
Can I talk to your co-author?
I'm not sure.
I would very much like to talk to your co-author.
Well, he was a graduate student. He went back to China 2 years ago.
Can I have his contact information?
He is in China. His name is Sam Lee.
I think I cannot use your data.
You could check the article to see if what you need is there.
Please stop talking now.
Okay, so I hope you all found that as funny as I did when the first time that I watched it. But what the YouTube video is attempting to describe is a real breakdown in terms of research data management principles. Clearly, this researcher, when they did their research, had a number of issues that they didn't anticipate. They never anticipated that they would need in the future to share their data with another researcher, and they did not come up with an adequate storage and sharing policy for the eventuality that the white panda bear may need some of their data. In addition, they didn't organize their data very well and didn't apply some very basic sort of organizational and knowledge management principles, including sort of file and folder storage, as well as making sure that the storage of their actual data was done in such a manner as to be reproducible. For instance, they stored the data as a hexadecimal file that required a specific program to decrypt, and that decryption program had gone out of business. So these are additional barriers that they're placing in the way of that data being shared. Once the data is actually decoded, all of the files and folders and the data itself in the fields is actually just labeled with a researcher's name +1 and doesn't actually describe the information that they were recording. So this is a breakdown of data management principles. And when research data management principles are not followed, they can lead to similar issues like this. In addition, when research data is not able to be adequately produced or reproduced, it can lead to major problems when researchers make big claims or publish and then are not able to back up their published results. So this is talking about UBC researchers pulling papers linked to vaccine components and autism after another author alleged that that data was manipulated, and the lab could not confirm that that information had not been manipulated, and so this led to further issues. In addition, Dr. Brian Wansink, famously at Cornell, had a lot of articles retracted because the authors simply could not reproduce and share the data with authors that were requesting this, as their research was showing very different results. So they didn't have access to the original data, and they failed to properly document and preserve the research results, which led to a number of retractions. And indeed, Dr. Brian Wansink no longer works at Cornell University following an investigation. So that is why it matters. That's why it's important, and that's some of the major topics that we're talking about here, why these things are really important. I'm going to take a really brief moment here and just ask if there are any questions in the chat. Raluca, if you could highlight those for me so I can talk a little bit about them. But then we'll move on into sort of research data management 101 and what it is and how it works.
No questions right now, Tom.
Perfect. Stunned silence. That's what I love to hear. So we're going to talk about research data management 101. We're going to break these down into some real digestible and important components so that you can understand sort of when we're talking about research data, what research data is and why it's important. So when we talk about the aspects of RDM, there are three things we really need to pay attention to, and it's media, format, and metadata/documentation. And they really go in ascending order. So media is the largest sort of box, format is a subset within media, and then the metadata is informing the format. Documentation, while it sits at the bottom, it kind of also exists in parallel to it, and we'll talk about that in a little in a few minutes. So that it works like this: media, format, metadata/documentation. And as our technology has advanced, our storage mediums actually become less and less future-proof. And this is actually a pretty big issue. And so to demonstrate this, we're going to talk a little bit about the original media, which are stone and clay tablets. And so initially this said forever. I make the argument it's forever-ish. These media are still sort of vulnerable to degradation over time. But this is one way that you can preserve results, preserve thoughts, and preserve information into the future. But paper, being a relatively new medium, it really only exists for about maybe 100 to 200 years, even in the best of conditions, before it starts to break down. And so paper, while being much more usable, arguably, than clay tablets, actually, even though it's more usable, doesn't exist for as long, and its redundancy needs to be planned for. But don't worry, because we've invented cassette tapes. But cassette tapes are actually even less future-proof. One, they're a form of media that requires specific technology to use that may not be widely available. Although I'm sure when this was initially published, they thought that this would be around forever. But it doesn't last as long. The magnetic strips inside of it actually break down. The technology may not be widely available, like I said. And so this typically only tends to last 30 years as a rough rule. CDs and DVDs, massive improvement in terms of the amount of data and the transferability of data, but they only last about 10 years before they're rendered inoperable. Again, this is sort of the median. But there are CDs that last for a very long time. There were also CDs that may break on day 2. There were, clay tablets that, a lot of them were made. Some of them were broken, but they tend to last a lot longer, even though they're a less efficient data medium. And then hard drives, and I can personally attest to this as being the victim of broken hard drives. These typically only tend to last 5 years, and actually that 5-year mark is, in some cases, pretty optimistic. And when they crash, when they die, they are typically not very easy to resuscitate. There are, modern storage techniques that can make this a little bit easier, or may recover some of the data, but hard drives are notoriously prone to failure. And so this is something that we should be aware of as well. This is media, so this is the top level. So this is how you choose to sort of store things and share things. Remember also that cloud data is just a hard drive on somebody else's computer. Cloud data is still stored on hard drive formats, although they may have backup capabilities that allow you to, if one were to fail, it wouldn't actually delete your data. And so this is something to keep in mind, the ephemerality of information storage. But formats. So file formats are what we're going to talk about today, obviously, because formats have existed previously in the past. But in the modern language, we really talk about file formats and how they work. So file formats rely both on software and on hardware to remain fully useful and accessible. And maybe you're saying, like, I don't understand, PDFs are pretty universally accessible, but PDFs are actually a proprietary form of file storage. The best things to use for long-term access to files are CSV, comma separated value files, .txt, which is just a text file, .gif, probably not the best storage format, but these are open access. And so anyone and a lot of different programs can access these. Proprietary means that file formats are owned by a particular company or organization. And so this, for instance, is the .pdf that we're also familiar with from Adobe, .doc from Microsoft, or .docx, .xls for Excel. I'm not super familiar with .shp, but these are all owned by companies. And so it can be difficult to access those file formats if, for instance, the company goes under, perhaps unlikely with companies like Adobe and Microsoft. But they can also be locked, or they can only be accessed via specific programs. So at this point, you have to say it's not just the computer that stores them that's the issue. It's also the software that accesses that information on the computer or the hard drive. So these are all things that you should be keeping in mind when creating your research data management plan and when planning for the future in terms of sharing your data and research data. So format. It's important to remember that you can have more than one format. You can store data in .txt, .csv, .xls, .doc, .pdf, etc. In fact, reproducibility and having more than one copy in more than one format may actually be ideal for longevity. The format best for your analysis is what I will always recommend, but that may be different. Like when you're doing your research and you're creating data, the long-term storage may look very different from the format that you choose for your short-term investigation. And that's perfectly fine, but it should be represented in your research data management plan and in your sort of research data management sort of general principles when you're thinking about things like this. I used, hopefully you find it humorous, Indiana Jones and the Last Crusade. This is a way of storing data for the long term. I don't think it's a particularly effective format, and I don't think that the media that a lot of this information is stored on are particularly good for long-term accessibility. One of the things you should keep in mind is that while hard copies can typically, last maybe a little bit longer, they sacrifice the shareability of the online media formats. And so that's something you should keep in mind as well. It's not just about longevity, it's also about shareability. And so moving on, so we've gone one step farther down. We've talked about the media, we've talked about the formats. Now we're going to talk about metadata and documentation. Documentation, I'm going to cover that first. It's sort of off to the side. It's information about your research process and methodology. It's basically you describing how you're going about doing things. So for instance, this could include survey instruments, servicing, etc., like documentation about the tools, as well as your lab protocols. So that's documentation that should be kept with your RDMP. But metadata, at its simplest format, is just information about information. So you've got a file, maybe you've got, I tend to use photographs. We've all got a smartphone. I actually forgot mine for a second. We've all got a smartphone. We've all taken photos with our smartphone. The second you take a photo, a format is created in the form of probably a RAW or JPEG file. The metadata around that file is things like when it was taken, what device it was taken on, who owns that device, the device name, the name of the file, the actual JPEG or .RAW file. So that's information about information. And you should be aware of this. For instance, if you take a screenshot of a JPEG, you immediately destroy all the metadata associated with that JPEG. So a lot of information does not carry on. And so if you do that in your research data management plan, you should be aware of the information that you're losing. And ideally, you should have a plan that allows that information to carry forward. So something to think about throughout the rest of this presentation is think about what extra information you would need to record about your research data if I, for instance, were interested in recreating your results and recreating your data. So this is just something to think about, just something that you should ponder as we move through this. But now we're going to talk about research data management plans. And again, before we continue into this, are there any questions about sort of the general principles of media format and metadata? Anything in the chat or any burning questions before we move on?
There is one question. How long do solid state hard drives last?
Solid state, that's a great question. So for those of you who don't know, there's the traditional spinning hard drive disk, the HDD, which is essentially, it is essentially a CD drive. It's a CD that's constantly turning, and there's a little reader that reads the information off the CD. So when you put things on, you're writing on the disk. When you're taking things out, you're reading information off that disk. That's how a hard drive works. A solid state drive actually doesn't have those spinning components. I don't have the particular information about how long it lasts off the top of my head, but they are significantly more reliable than your average hard drive. The issue that goes along with solid state drives is that they're extremely expensive. They are significantly more expensive than your average hard drive disk, although that may change, depending on the craziness of today's modern economy. But yeah, typically those are the downsides of the solid state drive. They're longer lasting and more reliable, but also much more expensive. And if you have, terabytes of data or even petabytes of data, maybe the solid state drives would be a poor financial decision for a researcher. Maybe the hard drives would be better. But that is a fantastic question. Anything else?
No, that was the only question so far.
Wonderful. So let's keep moving and talk about the RDMP, the Research Data Management Plan, which I've been referencing throughout this presentation. So the RDMP is just a document that describes the data that will be collected throughout a project and how that data is going to be organized, stored, and shared. These are three really important things. We want to keep our our data in accordance with the FAIR principle, the findable, accessible, interoperable, and reproducible format. We want to be aware of people may be asking for this data, so we should be able to share it. The data should be reproducible, so someone should be able to come in and say, oh, I know how you did this. I know the technology that you used, the procedures that you used, et cetera, so that they can reproduce it. They should be able to find you in the first place, so you should be trying to make your data as available as possible and as searchable as possible. And we'll show you some means to do that in a second, but and it should be stored effectively. Now, an important asterisk here is that if disasters happen, that is something that happens. It's obviously, a bit of a tragedy, but you can only take so many sort of reasonable steps to preserve your data. No one's asking you to engrave all of your findings onto clay tablets and keep them, next to the Ark of the Covenant. That's not a reasonable request, but we should be thinking about how our information and data are being stored into the future, because it's important that we at least try our best to share this information with future researchers and colleagues and collaborators. So what is the RDMP going to do? It's going to define the steps you need to manage your data. It's going to strengthen your research ethics application. It's going to ensure you follow funder and journal requirements. It's going to clarify what you need for longer-term data management. So it's going to list what you're actually going to be doing. It's going to give your data a longer lifespan and strengthen your research process. And the source of all this information is the University of Alberta's library research data. So it's going to make your applications and your research process more robust, is essentially the only way I can define it. It's going to make your lives a lot easier in much the same way that I've talked about citation management and citation managers as being sort of like lifestyle, improvers for researchers as a way of keeping your information organized. The RDMP keeps your entire project organized and allows you a little bit of future proofing because you've put the extra thought in. The RDMP describes how your data is going to be collected, documented, formatted, protected, and preserved. How existing data sets is really important for us as health researchers. How existing data sets will be used and what new data will be created over the course of the research projects. Whether and how data will be shared. Sometimes there is data that should not be shared, or at least not be shared in its raw format. Where that data is going to be deposited, you should have a plan for where it's going to go. Who's responsible? It's going to be detailing, specific team members, for instance, may have different responsibilities. Some may be responsible for initially controlling versioning. Some others may be responsible for the archiving of that data afterwards. Succession plans. This is a big one. People leave research projects. People don't finish research projects. New collaborators come on. The succession plan should be in place so that if someone leaves or comes on, that they're able to be onboarded into the research data plan so that they're sharing things in an accessible format as well. It should identify the data-related roles. Basically, it should give everyone on the team something to do in regards to their responsibilities for making sure this data is both reproducible, interoperable, findable, et cetera. And the responsibilities of other team members where appropriate. We don't think that everyone needs to be always engaged in research data management, but there should be specific people whose responsibilities sort of continue on throughout the project. For us, it can outline the ethical, legal, and commercial constraints that the data is so subjective to. I'm sure we're all familiar with the legislation surrounding, for instance, patient health information, how that can be used, when it can be used, how it can be shared. That should all be included in your research data management plan, and it's extremely important that it is. And for obvious reasons, you do not want that information being shared with the public or with malicious actors by accident. Which data repository has been selected for data deposit at the end? Now, repository is a big word, but essentially all it means is that you need to have a place for this data that can be stored safely. That can be multiple different hard drives. That can be on something like T-Space or RDRD or FRDR. Sorry. Which we'll cover in a little bit, but it's just important that you have that plan in place and that you're transparent about sort of the positives and the negatives of that plan. Not everyone has the ability to just store everything in boxes, nor do I think that that's a great idea. And in modern times, there are many services that are available for you to store your data for the long term, again, which we'll talk about in a second. That's something that you kind of have to make a decision for yourself. when we get to the folder structure, we're going to be much less restrictive in what we allow people to do and what we say is best practice, because ultimately a folder structure reflects the team that uses it or the person that uses it. Just try to remember that if a new person came in, would they be able to understand where your data is living in this folder structure? Again, we don't have to get into that as much, but if you have further questions about it, happy to chat about it. Versioning control, this is something that happens a lot. Whatever versioning control works for you is good. I've given you two, oh, sorry about that. I've given you two examples here using the example that we used before, the file naming structure that we used before, v1, v2, etc. But some programs actually have automatic versioning, which can be very helpful. And in those cases, I think that those are powerful tools that you should be using. If you still wish to do versioning control like this, you can definitely do that. That's entirely your decision. The 3-2-1 rule. At least 3 copies of your data on at least 2 different types of media. So remember, it can be paper or digital, or it can be hard drive and SSD, just 2 different types of media with at least 1 stored off-site. There have been times that buildings have burned down and destroyed everyone's data. You should be preparing for that eventuality so that you can avoid that admittedly horrible outcome. Because there are worst case scenarios. For instance, this is a real story. A grad student's laptop was stolen, and it included his entire thesis, all of his information, everything that he'd ever worked on, just on that one laptop. Now, in the modern era, that's less and less the case because people tend to store things on things like OneDrive, SharePoint, Microsoft Teams, Google Drive, etc. These more cloud-based solutions that allow you to work between multiple computers. But I still encourage, again, save one in the cloud and one on your hard drive, and try to keep them both as up to date as possible. In order to prevent, for instance, that like a cloud service goes down or loses your data, or there's a data breach or something like that, you still have that physical media, as well as if your laptop is stolen, you still have that online versioning. Ethics and legal implications. Again, this is going to depend on the kind of project that you do, but you should consider what's covered under copyright. That can be really important. Who owns the data you are using and or collecting? This is really important when it comes to things like PHI. What are you legally allowed to do with this data? There are obviously ethical and legal attachments that come with collecting people's personal information, and you should be both working with your ethics research board as well as just implementing proper data sharing practices within the research data management plan in order to control for this. Are there ethical considerations in particular to your data? For instance, are you collecting the data of children, right? There are research projects that work with children, but there are specific considerations for working with those age groups that you should be keeping in mind. Again, a lot of this you work through with your ethics research board, but these are things that you should be thinking about even before that step. Your documentation. So it should include a project overview, the methodology for everything you're doing. A lot of this is done already by researchers, but it's in a more formal manner in the DMP. Your work logs, your logbooks, your protocols, your lists, include all of that and make it shareable in some format for the future, and document as often as you need. It says daily, that's just at the end of the day when you're wrapping up in the lab or whatever, just save everything or have a procedure in mind for keeping the information generated that day safe and accessible. Think about the fact that your building could burn down, for instance. Metadata, on the other hand, it's structured information that describes, explains, locates, or otherwise represents the research data that you're creating. So documentation for a research project, this is, things are often written down, your protocols, etc. Metadata is generated automatically. And so you should, in whatever way possible, attempt to preserve that metadata. Like I said, the easiest way to explain this is preserve it. Don't take a screenshot of a photo, save the photo itself, or copy the photo itself, because that will preserve its metadata. Sometimes this is not possible. If it's not possible, clearly describe why in your research data management plan. We're going to talk a little bit about the types of metadata here. Descriptive metadata like file names and variable names. Technical metadata might include properties of the file itself, for instance, like when it was taken, its geodata, etc. Administrative data might include its user license or sharing agreement. A lot of these may not apply to all data collected, but these are obviously things that you should be thinking about within your research data management plan, even if it's just to say it's not applicable. Structural metadata. So this is your file and folder names. When you transfer your files and folders over to your preservation station, you should be thinking about this because you want to preserve as much of the original context of your research as possible, and file and folder names are part of that. Just to once again clearly separate these concepts, the metadata is like who created the data, what is the data, when was the file modified or created, where was the data collected, etc. All generated automatically, all should be preserved. Documentation is, well, it's documentation. It's about how you did things, what you did, how you did it. Typically written in a longer format. These may be, Word docs or text docs, etc. But that's how you sort of delineate that in your mind. A research data management plan takes all these previously discussed things into consideration. It is a living document. It does not sort of get sealed away. It is constantly revisited as the needs of your research project change and your data management practices need to change. For instance, if a program that you were using, suddenly went out of business and you needed to change the way that you saved your files. It's a relatively small amount of work at the beginning of a project, and we're going to talk about some tools that will help you with it. But it's a valuable step, and it will save you time in the long run. It's going to save you a headache at some point. One of the tools I want to highlight here, and again, we're going to get a little bit of a talk from UHN Research. We're going to talk about their own DMP assistance and their own plans sort of around that as much as possible. DMP Assistant is a free, online, and available tool that essentially it systematizes the creation of a DMP. Now, one of the things I do want to cover here is you do need to create an account. It's completely free, but in the creation of an account, you need to select the institution that you belong to. Michener and UHN are not in those lists yet. What I did, and what I would recommend anyone do, is I selected, the University of Toronto or whatever institution I felt best reflected my institution, because it's in close proximity, obviously, and I just used their DMP. Now, there are some problems with it. For instance, the resources they tell you to contact, those are U of T specific. I don't have access to those, but the questions that they ask, really the utility of the DMP comes from that. So they're asking you specific questions like, much like this presentation did, like where is this information coming from? Who's collecting it? Who's in charge of it? Is there a plan for longer term preservation? It asks you these questions in a structured manner so that you can write your DMP with those prompts. And that's where I think the utility of this program lies. It's not to say that you need to be a member of U of T. In fact, I think that the institutional affiliation is almost it's almost ephemeral. It's not very important. What's important and where the utility comes from is the questions that it's going to be asking you during the creation of your DMP. I hope that at some point UHN is on that list, at which point I will switch to using the UHN program or the DMP assistant. And at the moment, I think you can make perfectly, you can make do very well by using whatever institutional affiliation you would like. I've used Ontario Techs, for instance, in the past, and it was quite good. This is what it looks like. This is just to show you sort of like how this kind of plays out. You can create a plan here. There's a U of T DMP question guide, the DMP checklist to make sure you've gotten everything. Again, there may be some specific checklists that are specific to U of T, but a DMP is made better essentially by having more variables taken into account. So this is an example of some of the questions they ask. Who is responsible for the data? Who can access it? Who is the main researcher, principal investigator, or co-investigator for the study? Is the study being conducted by only you, or are there members on a team? You can see where the utility of these kinds of questions come into play. And it breaks it down in different ways. This is, for instance, administrative information. Data deposit. We're almost done, and then we'll have time for UHN Research to come up and talk. I'm very much looking forward to it, actually. Data deposits, all research data collected with the use of SSHRC funds, for instance, must be preserved and made available for use by others. This is within, if you use SSHRC money to do research, this is a requirement from the research funder. SSHRC considers a reasonable period to be within 2 years of completion of the research project for which the data was collected. So you are required, if you take SSHRC money, to share your research data upon request within 2 years. CIHR has a very similar requirement: deposit bioinformatics, atomic and molecular coordinate data into the appropriate public database, gene sequences deposited in GenBank, immediately upon publication of research results. So they're actually much more specific. The data that you were collecting, specifically, bioinformatics, atomic and molecular coordinates, but I encourage you to do this with all data you collect, assuming that it can be ethically and legally shared, should be deposited in some sort of publicly accessible database. I'm going to give you a few that are an option, but they should be in some way findable and searchable. In many institutions, it's called an institutional repository. UHN does not have one of these, so I've given you some publicly accessible options. And this is the full tri-agency statement on principles of data management. Grant recipients are required to deposit into a recognized digital repository all digital research data, metadata, and code that directly supports the research conclusions in journal publications, preprints, and other research output that arise from agency-supported research. So this is their policy. If you are using money from the Tri-Council, this is something that you should be keeping in mind, although anyone doing research could benefit from research data management and research data management plans. Two options here for you for research data management and depositories and institutional repositories. FRDR, it's a publicly accessible repository. You can deposit your research there. It addresses they address a long-standing gap in Canada's research infrastructure by providing a single platform from which research data can be ingested, curated, preserved, discovered, cited, and shared. That's one option. T-Space is the U of T's institutional repository. I probably think that we have a few people who are affiliated with U of T here. Highly recommend you get in contact with their research data management team and use T-Space, which is their institutional repository. Just some options for you there. Again, you can make the decision about how you share it, but it must be shared in some sort of recognized manner so that other researchers can use your data upon request, assuming you took that research funding. So there's now the Q&A period. That was a lot. I'm going to invite, I believe it's Michael Voth, up to talk for a few minutes about this, and hopefully share some more UHN specific resources and some more UHN specific plans about research data management and research data management plans. Michael, if you're there, you can feel free to unmute.
Yeah, hi Thomas, thanks a lot. I thought this presentation was really timely and really great, like not just the video with the bears, which was worth the price of admission in itself, but all the considerations and leading practices you shared throughout. So it's also great to hear about the guidance and support your team provides around creating data management plans and selecting appropriate data repositories, as you mentioned. So we look forward to continuing to work with you and co-learn with you and Tim and his team and to support these efforts. I know we're almost at time, and I want to make sure other people have lots of time for questions, but appreciate the opportunity to highlight some of the work going on at UHN currently. So as you mentioned, like all TASN organizations and other tri-agency funded organizations across the country, we're in the process of drafting and finalizing an organizational UHN research data management strategy to support the tri-agency requirements. So this has actually been a really good opportunity for our organization to come together and step back to identify and consolidate what our strengths are currently in supporting RDM at UHN, and to identify priority areas evolving digital environment. So we struck an RDM strategy working group composed of some of our scientists and digital experts and regulatory and policy people to bring this together. And we surveyed the entire UHN research community in late 2022 to better understand what's going on the ground, what's going well, where can we improve and focus on going forward. So thanks to everyone who on the call who may have contributed to that and therefore contributed to UHN's RDM strategy. Among the priorities people will see highlighted in the strategy document when it comes out in the coming weeks, it's making sure that we not only have, but widely promote the various secure platforms and options for storing and archiving data, as you mentioned its importance. Establishing a centralized framework for the creation of internal and external data registries, for example. Ensuring we have guidelines and support when working with data from Indigenous communities to incorporate OCAP and CARE principles into research data management in that area. Developing very clear data management sharing policy and standards and options for depositing data, whether it's in a public or restricted data repository to promote sharing and reuse. So there are several other priority areas in the strategy, and I just wanted to highlight this issue of data management plans because it's so important. As you mentioned, we're looking closely at the DMP assistant from the Portage network. So I think that's something that we can take a close look at having a UHN link to. I think people can also find some great DMP examples on the Digital Research Alliance of Canada website. I'm happy to share that as well. I'm sure you've seen that. We're in the process of finalizing some DMP templates and guidance currently that incorporates many of these key ingredients from the Digital Research Alliance, the Canadian Tri-Agency, and the NIH, as well as some UHN specific considerations, language, and policy reference. And we'll be circulating and posting those in the coming couple of weeks as well. So we encourage everyone to look out for these, along with contact information for people like yourself and others who researchers and staff can reach out to with help in developing their management plans. So again, just really look forward to working further with you and your team and co-learning with the whole UHN research community going forward. Thank you.
No, thank you, Michael. It was great to hear from you, and I'm really looking forward to seeing a lot of those new resources come out for people here. We do have time for questions. I understand if people do need to leave, but I'll be available here if you have anything that you want to ask. Melanie, do we have anything that needs to come up? Oh, sorry, Tim. Do you want to speak for a minute?
Yeah, sorry, Melanie's been having some technical issues, and Raluca had to leave, so I'm playing both parts right now. There were some more questions in the chat. Let me see. I'm going back a bit. We dealt with that one. So Charlie was asking, what does it mean by commercial constraints? Unfortunately, I don't remember the context of that question, but if Charlie's still on, you could always unmute.
I don't want to jump the gun, but I think what Charlie's speaking about is some of the restraints on data and data sharing, including commercial restraints. And this can have a number of meanings, but one of the most prominent is from time to time, researchers do work with private entities in order to do research. And there may be sort of commercial restraints in how information about certain products or certain research is done. In terms of it could affect that private corporation. That's one example of a commercial constraint. You should be where you should be mindful of your partners, corporate partners, private partners, whatever, may have specific restrictions on how you use data. For instance, there may be a proprietary software that you use, and they may request that you keep certain aspects of it private for them because it's their intellectual property, et cetera.
Okay. All right. Thanks, Tom. The next question was from Thomas Walton. Thoughts on GitHub repositories for data storage and sharing?
I love GitHub myself. I think that it's probably not the most perfect solution. Again, though, if you're creating code and you want to share, that publicly and make it open access, and you think that GitHub may be a good, resource for that, I think that's appropriate, assuming that you are not, legally or ethically bound to not do that. I think that GitHub is a great resource. I do think, though, that some of the resources that both Michael and myself have shown off may be a little bit more appropriate for showing the sort of entirety of the research project. Although GitHub may be a component of your preservation strategy and your sort of access and sharing strategy. Yeah, I think GitHub can play an important part in that. It really does depend on the research project, though, and how you want to go about sharing that information. Right.
Yeah.
Lots of. Oh, sorry, Tim. Go ahead.
Oh yeah, no, I was just thinking, like in my own mind. Granted, I haven't looked at it in ages, but I always associate GitHub with software code. So, but okay. All right. Let's see. Next, Jermaine asked for file names that also use a time in it. What's the proper format? I don't know if there's one answer to that.
There's not one answer to that. It really does. If you need to be that granular, there really is. There's a number of solutions. I still maintain that you should do it sort of chronologically from like the biggest block of time down to the smallest. So what I would recommend is a year, month, day timestamp with no parentheses in the time. So for instance, like 2022, 03, 11, 10, 25. For instance, if you need to be that granular, if it's a requirement for the data, or if you think it's important for that, that it is a form of metadata, that metadata to be preserved. So that's something that you can definitely take the time to do if you wish.
And I would imagine, there could be different formats, but as long as they are defined clearly in some sort of data dictionary and you're consistent, I don't know if there's whether that would necessarily be dictated. Let's see. The last question I see here from Tanvir is RDMP only in writing and then save the Word doc as a file, or save the strategy in the DMP assistant tool? Or there's more. Or does the research team need some server space or repository to put archive metadata and data version history, etc., to be transparent and meet the new TCPS policy?
I'm not. Sorry, I'm going to answer this, I think, in pieces. The RDMP does not only need to be in writing; it simply needs to be accessible in some manner. If you feel that it's, I think probably most of them will be in writing, and use writing to talk about the strategies that are being used for research data management and the research data management plan. But you may include, like other instructions if they're useful. And then saving the Word doc or file, save the strategy. I'm not totally certain about this next part. DMP Assistant, if you wish to upload your plan, will accept a number of different file types. But save the Word doc. I would probably not save your RDMP as only a Word doc. I would also save it as a .txt file for maximum accessibility. .txt files can be read by a number of different programs, not just Microsoft Word, although Microsoft Word is obviously a kind of a gold standard or industry standard for word processing. It's not a requirement that you have server space / repository. It's not a requirement there. It just needs to be accessible in some manner. And depending on how you interpret the wording, maybe it would need to be sort of directly accessible from another researcher. They'd need to come in and use a repository and sort of find your information and be able to directly download it. For myself, the way that I interpret it is it does need to be transparent. People need to be able to find that information, but you don't need to, for instance, pay for server space for yourself. In many cases, that's taken care of by third parties. So, for instance, like the FRDR, Digital Research Alliance, T-Space, et cetera, it can be institutionally affiliated or it can be publicly accessible and available. So it's not a financial requirement for the researchers to have that. But it may be beneficial to have that. You may have server space, and by server space, we can mean even something as simple as like a Google Drive, where you keep a lot of your research data, again, in keeping with your research data management plan. So that would be something that you'd have to decide before you started generating data, or at least you should decide before you start generating data, and use that tool as a repository moving forward. Now, I would say that's not the most findable, but it does allow you to keep that, again, for future reference, as long as that information is in some way usable. I feel like that was a very long-winded way of explaining that, but if there are any sort of specifics that you want to get down to, I think that might be more helpful for you, because it sounds like you may be dealing with an actual specific issue. If anyone has any additional questions, by the way, feel free to write them in the chat or unmute yourself, I guess.
Yeah, we've gone well over, and we've still got quite a few people who are still hanging around. So I guess there's definitely interest in this discussion. There are no more new questions in the chat. So I'll give one last opportunity. If anybody does have another question, you can either put it in the chat or unmute yourself. I think Raluca did take off the restrictions on people unmuting themselves before she left. So otherwise, we'll wrap up. Okay, I'm seeing nothing. I'm hearing nothing. Anyway, thanks, Tom, for that. That was a great session. Again, the video with the bears, I've never laughed so hard. Look at it. Yeah, I suspect we could all relate to that in one way or another. And yeah, so that was great. Thank you for this. Thanks, Michael, for popping in and talking about what UHN's plans are around research data management plans, and we look forward to the upcoming communications around that. So thanks again, and thanks everybody for joining us on this, our last library-related workshop of Teaching and Learning Week 2023. So
Thank you so much for having me in.
thanks, Tom.